Hello and welcome to the practice portion of our video. Here we have 1-2, so you should have already taken the notes for 1-2. We talked about line measures and specifically line segments. We're going to take a look at the odds for the most part. We're going to actually skip over to the evens towards the end. But just taking a look at it, we're going to do some odds. And you should be able to do the rest. So for instance, identify which point is between the other 2 points and find the measure of each segment. Assume that each figure is not drawn to scale. And so S is clearly in between R and T. And we want to find this length from R to T. And hopefully this is obvious because all you do is 2.0 plus 2.5 is equal to 4.5, or in other words, RS plus ST is equal to RT. And this is a line segment, so you do not have to put the arrows above it, and we are done. You should be able to do 2 on your own. And let's take a look at 3. There is a little hint here. It's asking for the WX. If you want to put X is between W and Y, you could, because that answers the first part of this question. W and Y. Now, the 2 tick marks is your big clue. Now, normally it'd just be 1 tick mark because it's the only line we see. But even if you see 2 tick marks, it just means it should be the same length as anywhere else you would see 2 tick marks. So, if you want to do this algebraically and properly, you could say 2x is equal to 6 centimeters. Divide by 2, divide by 2, and hopefully this is obvious. X is then equal to 3 centimeters. Thus, we would have WX is equal to 3 centimeters. Now you could also just do that obviously, because half of 6 is 3. 3 plus 3 is equal to that 6, giving you that length. Further the diagram, there we go. LK is congruent to LK. Well, so we see the 2 tick marks. We should be able to identify the other 2 tick marks, which would be JK. Okay, you should be able to do 4 and 6 on your own. Let's take a quick look at 7. And one thing I did want to address is that this is actually a typo on here. I'm not sure if your printouts have the same thing, but in case it does not, those should be congruent symbols. Mark CD is equal to EF. CD is equal to EF. Notice I use 1 tick marker. AF is congruent to, I'm going to use 2 tick markers now. ED, which is also congruent to BC. Okay, and that's what it's asking for. Now, we don't have one for AB, and that's perfectly fine because it does not show it. Here's where I wanted to do 8 and 10. So even though this last one was 7, we got to do a little bit of extra. We have to draw the diagram for sure, and that I would definitely recommend draw. Anytime you don't have a diagram, draw the diagram and try to piece it together as best as you can. Now, find the value of X and RS if S is between R and T. So every single time we're going to do this, R we have T, and then S is in the middle. S is not necessarily perfectly in between it, and we have to find out the value. Find the value of X and RS. So we have to find 2 things. We have to find what X is, and we have to find what RS is. And we could do that. So RS in this case is 2x. ST is equal to 32. And we have to find what the length is completely. So simply put, RT is equal to 5x plus 2. So we could put 2x plus 32 is equal to the full length of RT, which is given 5x plus 2. Okay? Doing some math. If you want to put the line dividing it, that's awesome. If not, that's okay. I'm going to bring the 2x's to the right side. Get rid of this. We should get 3x plus 2 is equal to 32. Then we subtract 2, subtract 2. We should get 30 is equal to 3x. Divide both sides by 3. You should get x is equal to 10. Now this is only part of the way because it says it asks for x and rs. So if we plug this back in, we could say rs is equal to 2x. Rs, is equal to 2 times 10. Rs is then equal to 20. Doesn't have any units, so you can just leave it at that, and we're done. You should be able to do number 9 on your own, but number 10 is the one that I definitely want you to follow along with because we're getting a little bit back into our algebra quadratic unit. Now, just like the last one, we're going to say R, and I should put the R on the other side. T, and then I'll put S somewhere in the middle. Doesn't have to be exactly in the middle. And let's do some labeling. RS is x squared. ST is 2x plus 1. And then RT is 9x minus 9. So that is that length. Okay? And just using our addition formula, RS plus ST is equal to RT. It's x squared plus 2x plus 1 is equal to 9x minus 9. Now, if you remember how to do something that's quadratic or has an x squared, typically you could bring everything to one side of the equal sign, and it'd probably be easier to bring everything to the left side. So I'm going to do this, bring the 9x over and bring the 9 over using opposite operations. These all cancel out on the right side. We should get x squared minus 7x plus 10 is equal to, and notice there's nothing on the right side, we put 0. Okay, now, here's the kicker. How do you solve quadratics equations? And hopefully you remember, and if not, that's perfectly okay. There are 2 ways to do this. Typically, you could use guess and check, and then you could find 2 values in which we have x and x to make this x squared. And then we need values that would fit the rest of this equation properly. You could always do guess and check. I'm not a fan of that. I've always taught it by making this diamond. Okay? And you put the C term, this is your A term, which is 1, your B term, and then your C term. You put the C term on top. You put the B term on the bottom, and you want to try to figure out 2 numbers that end up multiplying to the 10, but adding up to the negative 7. And what we would do here is we would see, oh, well, we know that 2 numbers that add up to negatives have to be negatives, and we need 2 negatives to add up, to multiply to a positive. So what happens if we put a negative 5 and a negative 2? This works out perfectly because we only have negative 5, x minus 5 and x minus 2 is then equal to 0. To solve this properly, we have to split this up. We would say x minus 5 is equal to 0, and then x minus 2 is equal to 0. Add 5 on both sides. Get x is equal to 5. Other one, plus 2, plus 2. We get x is then equal to 2. And we actually need to check these answers real quick, okay? Let's just check, just to make sure. I'm going to do this in pink because we're just checking our work, okay? Now, if you want to use the original equation, you absolutely could. You could plug it into this, and let's check. I'm going to do 5 squared plus 2x plus 1 is equal to 9 times 5. Oops, this should be a 5. Minus 9. So we get 25 plus 10 plus 1. And here we'll have 45 minus 9. We should get 36 is equal to 36. So 5 completely works out. Let's check the other one. What happens if we put a 2 there? Well, we could also see 2 squared plus 2 times 2 plus 1 is equal to 9 times 2 minus 9. 2 times 2 squared is 4. 2 times 2 is a 4 plus 1. And this makes 9. And just knock that out of the park. 9 times 2 is 18. Minus the 9 makes this also 9. And these both work. Okay. One thing you should check, though, is to see if one of these become negative. Okay. And the important part is length cannot be negative. So if I had a length here that turns negative, that's a big no-no. There's no such thing as a negative length. So we need to make sure when we do this to see that it doesn't have some negative outcome. And clearly in this case, 36 is a positive number in both cases. 9 is a positive number in both cases. So these both work out. Okay. Last one, find the perimeter of the triangle. And we're not going to go over this one, but I do want you to notice, these have the same tick mark. So that means these two are equal to each other. You should be able to solve it from there. Okay. Other than that, I trust that you should be able to do the rest of these on your own. If you do have any questions, please let me know, and I'll see you in the next one. Bye.